You can use chat, you can use mic, or you can use screen annotation to answer these questions. Try to participate as it's a part of the preparation. So even your answer is right or wrong, it does not make difference, but try to participate. In case if it is wrong, then I will do correction for that, and you will learn from your mistakes. So I want everyone to participate. You can use mic, chat, or screen annotation, anything which is convenient for you. In the first question, choose from the following oxides to answer the questions: aluminium oxide, calcium oxide, iron 2 oxide, magnesium oxide, silicon oxide, sodium oxide, and sulfur dioxide. The question is, which has a simple molecular structure? So which of the oxide has a simple molecular structure? The first thing, it cannot be ionic. Why it cannot be ionic? Because ionic is having, if you say silicon dioxide, then it's also wrong. Why? Because silicon dioxide is a macromolecular structure. So the silicon dioxide is not the right answer. Why it's not the right answer? Because silicon dioxide is a macromolecular structure, a tetrahedral structure, so a giant covalent structure. That's why it is not correct. The second one is a colored solid. No, not anything. Why anything is not acceptable? Look, aluminium oxide is ionic compound. Ionic compounds have giant structure. So ionic compound cannot be a simple molecular. That's why this calcium oxide also giant, iron oxide also giant ionic, magnesium oxide giant ionic, sodium oxide giant ionic, silicon 4 oxide giant covalent. So only option which we are left is sulfur dioxide. So only sulfur dioxide is a valid option here. Then it is a colored solid. So which one is a colored solid? The iron 2 oxide is a colored solid. Contain iron with a charge of 3 plus. So that is aluminium oxide. Is a product of a thermal decomposition of a calcium carbonate. So when we decompose calcium carbonate, it formed calcium oxide plus carbon dioxide. So calcium oxide is there. And the last one, contribute to acid rain. So it should be a non-metal oxide. And the most is a sulfur dioxide, which forms sulfurous acid or sulfuric acid, which leads to an acid rain. The question 2, dry air contain nitrogen, oxygen, noble gases, carbon dioxide. What is the percentage of oxygen? So by volume, it is 21%. That's right. Carbon dioxide is removed from a sample of air by passing through an aqueous sodium hydroxide. Why aqueous sodium hydroxide remove carbon dioxide? Yeah, it neutralizes, but you have to relate the nature. What is the nature of carbon dioxide? It will form hydrogen carbonate, but why? The first thing we have, so it is acidic nature. Like carbon dioxide is a non-metal oxide, which is acidic in nature. It reacted with sodium hydroxide. If it formed carbonate, it actually formed hydrogen carbonate rather than forming a carbonate. But you have to relate them, the nature of the compounds. Carbon dioxide is acidic oxide. Sodium hydroxide is a base or alkali. When acidic oxide react with an alkali, it will form a salt. And which salt is formed here? When sodium hydroxide reacted with carbon dioxide, it will form sodium hydrogen carbonate. So HCO3 will be formed. And this sodium hydrogen carbonate is actually water soluble. Describe how oxygen. So one mark is for mentioning the natures, acidic and alkaline nature, and one mark for mentioning acid react with an alkali to form a salt. In this case, the salt, because salt can be a soluble or it can be an insoluble salt, but in this case, it will form a soluble salt. That's why it will dissolve. Or you can also say a carbon dioxide is acidic oxide, react with an alkali to form sodium hydrogen carbonate or hydrogen carbonate ion, which make it soluble or dissolve. Describe how oxygen, nitrogen, and the noble gases are separated from each other after carbon dioxide is being removed. So which method is used to separate? Fraction distillation. Yeah, that's right. But which substance we carry out a fractional distillation? That's good. A liquid air. So fractional distillation of a liquid air is actually, so don't forget to mention a liquid air, because air, which is a mixture of the gases, first we liquefy and then we carry out the fractional distillation. So the one mark for a fractional distillation and the second mark is for the liquid air. In part D, describe the test for the oxygen, how you can test an oxygen gas. Glowing splint, that's right, and it will relight. So for oxygen, look, if you mention a glowing, actually, the appropriate one is a glowing splint, it will relight. Lighted splint, for example, if you mention a lighted splint, like me, so means the lighted splint, it will burst into flames. So for this one, if you mention a lighted splint, then the flame intensity will increase or it will burn at a high flame intensity, then that should be the observation. If you mention lighted, but lighted splint, that's why to distinguish lighted splint for hydrogen, which gives a pop sound, and a glowing splint, it will relight. So if you mention a lighted splint, then mention that the flame intensity increase, it will burn with a bright flame or a flame intensity changes. If you mention glowing splint, then it will relight. Ozone, which is O3, is formed in the upper atmosphere by the reaction of nitrogen dioxide with oxygen in the presence of UV. State the type of a chemical reaction that take place when ozone is formed in this way. So when ozone is formed, what we call this? That's right, photochemical reaction. Because any reaction which happen or occur due to the light, we call that as a photochemical reaction. Nitrogen dioxide is formed in internal combustion engines. State one other source of a nitrogen dioxide in the atmosphere. So other source, forest fire, right? Or lightning, you can also mention. Car engine is already given because they mention here nitrogen dioxide is formed in the engine. We need other source. Ozone, a layer of an ozone is present in the high atmosphere. State one problem for a human that can arise if the ozone layer is depleted by the CFCs, chlorofluorocarbons. What is the effect of the ozone? Ozone is having a tendency to absorb the high intensity UV radiation from the sun. So if ozone is depleted, what will happen? Greater amount of UV radiation will enter the atmosphere. So as a result, it may cause like a skin cancer, or it will harm the eyes as well, increase the risk of skin cancer. That's right. It can also cause damage the eyes, harms to the eyes, or can cause greater amount of sunburn. But don't mention global warming. Global warming is for ozone is not a greenhouse gas, So global warming is for because of the methane and the carbon dioxide. So don't mention a global warming in this one. Question 3, iron powder react with a dilute sulfuric acid. As you can see, iron plus sulfuric acid gives iron sulfate plus hydrogen. The graph shows the volume of a hydrogen gas produced at 20 degrees. State how long it takes from the start of the experiment to collect 18 cm cube of hydrogen. So what you have to do, you have to draw a line. Look, whenever you are using a graph, you should always draw the lines on your graph. Directly don't say the answer, even though it's a 1 mark. Like show that on your graph that you mark 18, and then from 18, you do a line on your graph and then work out the time interval. 6 seconds is the right answer, but whenever you're using a graph, always show that you by drawing the lines. The experiment was repeated at 30 degrees. All the other conditions are kept same. Draw a line on the grid to show how the volume of a hydrogen produced changes if the same experiment we did. Like first it was done at 20, but now we are doing it 30 degrees. So 30 degrees, it will be higher rate or steeper, but the final volume does not change as we are not changing the reactant. And how you label this? So this part you will label A2. On your graph, when you sketch this, label that this is A2. Or you can also mention 30 degrees. Describe and explain using the idea about the collision between the particles, how the rate of a reaction changes when the temperature of a reaction mixture increases. The rate of the reaction increases because when we increase the temperature, the particles have like sufficient energy or greater than energy, more than activation energy. They move faster, greater number of effective collision, greater higher frequency. So full structure you have to learn for this. Describe and explain using idea about the collision between the particles, how the rate of a reaction change when a large piece of iron are used. If you use large pieces of iron, the same amount, but the large pieces, how the rate will differ. Will it increase or decrease? If you use a large piece. So if you use large piece, what will happen? The rate will decrease because it will have a smaller surface area. That's right. And I appreciate those who are participating, like Mira, Rabia, Bushra, Afifa, Ghulam, Saim. And I expect from others as well because it's a part of learning. So try to participate. Either you can use screen annotation, mic, chat, what is convenient for you. Calculate the maximum volume in decimeter cube of hydrogen, which is formed from 3.36 grams of iron, react with an excess of a sulfuric acid. So what we have to do, the equation, and see the equation, the ratio is 1:1. So first what we'll do, it's of 2 marks. First we'll find the moles of iron. Moles of Fe. Moles equal mass in gram, which is 3.36 divided by the molar mass. In this case, iron is 56. So 3.36 divided by 56. That is 0.06 moles. So we get 0.06 moles of Fe by using the equation. The mole ratio is 1:1. So we'll get the same answer if 0.06. So this will be X. And yeah, that's good. After getting the moles of hydrogen, we just multiplied by 24. So we get 1.44 decimeter cube. Concentrated sulfuric acid is oxidizing agent. Oxidizing agent means itself it is reduced. So the substance which is oxidizing agent itself it is reduced. So what we can use here to test the oxidizing agent? The oxidizing agent help in oxidation itself it is reduced. So if I add potassium, one of the student mentioned like potassium manganate 7. Okay. If I add potassium manganate 7, in potassium manganate 7, the formula of potassium manganate 7 is KMnO4. Okay. In which Mn is already plus 7. This is -8. This is +1. And if you are using sulfuric acid H2SO4, sulfuric acid is oxidizing agent, means it oxidizes the other substance. So can Mn7 cannot increase. That's a maximum value of the oxidation number Mn7 can have. So this potassium manganate KMnO4 cannot be used as an oxidizing agent to test an oxidizing agent, because I want something which can oxidize when it reacts with sulfuric acid. KMnO4 is actually a test for reducing agents. If you want to test the reducing agent, potassium manganate 7 or potassium dichromate, these are the substances which can be used to test the reducing agents. If I want to test an oxidizing agent, what we can do? We can test with potassium iodide, Ki. So when sulfuric acid, H2SO4 reacted, if I use carbon monoxide will be oxidized, but there will not be a color change. That's what we want, a specific change in the color. So here we have iodide ion. When the reaction will happen or occur, as a result, one of the product will be iodine molecule. Potassium iodide, that is a colorless, and when iodine molecule is formed in the solution, it will be brown in color. So if you want to test the oxidizing agents, what we can do, we can add potassium iodide. And what is the observation? Changes from colorless to brown. And if the same question was there, how you can test a reducing agent, then what you mentioned in the beginning, like potassium manganate 7 or potassium dichromate 6, these are the tests for the reducing agents. If you mention aqueous bromine, you can mention potassium bromide rather than aqueous bromine. Because if you mention aqueous bromine and we have a sulfuric acid like H2SO4 and bromine is already this is 0. So we want oxidation to happen. So when a bromine is there, it is already 0, means that is the highest oxidation number which bromine can have. So sulfuric acid cannot oxidize it further. So you cannot use aqueous bromine, but you can use potassium bromide. Like if you mention use potassium bromide, then also it is correct. Because when potassium bromide, the bromide ion turn into a bromine molecule in which the oxidation number will be 0. So -1 turn into 0. That is also oxidation. And you will also observe the same color change. Either you can mention colorless to brown, or you can also say colorless to orange. Because aqueous bromine is orange in color. Is it clear? The test for the oxidizing agents. So try to write these points whenever you want to test oxidizing or reducing agent. These are the reagents. If you want to test oxidizing agent, potassium iodide or potassium bromide. And if you want to test the reducing agents, then potassium manganate 7 or potassium dichromate 6. Question 4 is related to organic chemistry. Alkenes are homologous series of hydrocarbons. Alkenes are produced by cracking. State the meaning of term cracking. So cracking is a breakdown of a long chain carbon into short chain by the help of either you can mention heat or catalyst, because there is a thermal cracking or catalytical cracking. So breakdown of a long chain into small, or decomposition or breakdown. But one important point, by the action of heat or by the catalyst. That's the important point. So when you mention long chain, long hydrocarbons turn into small chain by either you mention heat or you mention catalyst. Name of the catalyst, you don't have to mention for cracking, but there's a catalyst known as zeolite, Zeolite, that is used for cracking, but you don't have to learn the name. You just mention either by cracking or heat. Margarine is manufactured from vegetable oil using nickel as a catalyst. Name other reagent which we use. So we use hydrogen. So hydrogen is used as a reagent. State type of the chemical reaction which happened. So that is an addition reaction, because as you like, it's an alkene. It is reacting with hydrogen to form an alkane. The nickel which is used as a catalyst, the catalyst, how we identify hydrogen, because alkene plus hydrogen gives alkane. And for this, nickel is used. So from the catalyst, we can identify the reagent should be hydrogen, other reagent. The next one, you can also mention addition, or you can also say hydrogenation. That's also true. Ethanol is produced from a reaction of ethene with steam. Construct the equation for this reaction. Ethanol. What's the formula for ethanol? So C2H5OH, that's ethanol, and it reacted with ethanol is produced. So we want the equation for the production. So the product should be ethanol. So we'll have C2H5 will be the product, C2H5OH. So how it is produced when ethene, which is C2H4, reacted with H2O. As a result, it will produce C2H5OH. This reaction is also example of addition reaction, also known as hydration. Hydration means addition of the water. So C2H5OH. The next question, an organic compound contains 54.5% carbon, 9.10 hydrogen, and remaining oxygen by mass. What is the empirical formula of the compound? So we have carbon, we have hydrogen and oxygen. So 54.5, 9.10, and 36.4. So first what we do, we divide by atomic mass. So we'll divide this by 12, we divide this by 1, and we divide this by 16. What's the answer? 54.5 divided by 5. 4.541. And whenever you're writing during like the steps of empirical formula, don't round off and write the numbers to 3 decimal places or 4 decimal places, because don't need to round off in between. Then you divide by the smallest value in the combination. So you divide all of them by 2.275. So this will be 2, 4, and 1. So 2, 4, and 1, these are the ratio of the atoms, carbon, hydrogen, and oxygen. In question 5, magnesium undergoes oxidation when it reacts with aqueous silver nitrate. How the equation shows a magnesium is oxidized? So whenever you write a oxidation or reduction, you should always refer in terms of electron, even though equation can be in terms of oxygen, in terms of hydrogen. So because it lost electron or loses electron and turn into magnesium ion, that's why we call that change as oxidation. The reaction of a magnesium and silver nitrate is exothermic. Complete the energy profile diagram for this reaction. Label the reactants and the product and the delta H. Energy profile diagram for exothermic reaction. So in exothermic reaction, the reactant should have high energy and the product will have low energy. And you have to label the reactants as well. Yeah, that was correct. Reactant will have high energy, product should have low energy. So what are the reactants? The magnesium will react with silver nitrate, AgNO3. These are the reactant, and what is the product? It will form magnesium nitrate plus silver metal, and the equation must be balanced to 2 and 2. So here we'll have the reactant magnesium plus 2 AgNO3 gives MgNO3 bracket 2 and 2 Ag will be the product. In the question, you can refer ionic equation as well. That is fine. You can use ionic equation, the above mentioned ionic equation as well. Or if you only mention reactant and product, that's also fine. How we identify it's a silver nitrate? Because they mention here the reaction, that the reaction is between a silver nitrate and the magnesium. That's why we identify that this silver is from silver nitrate and this is a magnesium metal. And delta H, so even if in exam, if you write here reactant and you write a product, that's also fine. And some students, like I remember I gave one test, some students mention here time in this axis. So that's wrong. You have to mention a reaction progress on x-axis. In the energy profile diagram, it's not the time axis, it's the reaction progress, how the reaction proceed. Acidified aqueous silver nitrate is added to a solution containing halide ions. A yellow PPT is observed. State the name of halide ion present. If we get a yellow PPT, that's good, iodide. The scientific term, when, like example, iron is there, so we don't say iodine. We don't say iodine ion, we say iodide. So even if it is chlorine ion, we say chloride. If a bromine ion, we say bromide. So if you are saying iodine, then you should say iodine ion, ION, or directly you say iodide. Either iodine ion or iodide. Only if you say iodine, then it will be wrong, because iodine is refers to molecule and iodide is refers to an ion of iodine. Silver is a metal. Use your knowledge for the structure of the metal to explain why silver metal is malleable. Why metals are malleable? They have a lattice, ionic lattice, or a lattice of oppositely. If you mention oppositely charged ion, then it will be wrong. Why it is wrong? Because it's a metal. So you're not supposed to say oppositely charged. And we want to talk about the silver metal. This is not ionic. Like these points you have to overcome. You have to mention it contain a lattice of positive ions and the delocalized electron, and these layers can slide over each other. So you have to mention a lattice of charge ions or positively charged ions, not opposite, positively, because it's about the metal. And the layers of ion can slide over each other. So why metals are malleable? Because metal contain a lattice of positively charged ions, and these layers can slide over each other or slip past each other. Or silver has a metallic bonding layer structure and which can slide over each other. And ionic compounds are not malleable. Ionic compounds are brittle. Brittle means when objects break down with a very small amount of force without showing any deformation, we call that as a brittle. So ionic compounds are brittle. They can, it's not like a small force can break down, but they don't deform much or very small plastic deformation and it breaks down. In part E, the table gives information about the thermal decomposition of metal carbonates, calcium, magnesium, and sodium. Describe how the ease of thermal decomposition depends on position of these elements. So when you list these elements, like sodium is here, then magnesium, and then calcium. So when you compare sodium with magnesium, what happened to the thermal decomposition? When you compare sodium with magnesium, so it is less stable or it can decompose easily. And as you go down the group, like when you compare magnesium with calcium, what happened to the thermal decomposition? So it will become more. So as we move across, like so, when we move across a period, like sodium carbonate to magnesium carbonate, what we observe? We observe the thermal stability decreases. But as we go down the group, what we observe? We observe the thermal stability increases. You're not supposed to say the reason here. In A levels, you will learn a reason. You can just compare, even in terms of reactivity, you can also compare. We have the reactivity series. If you write the reactivity, we have potassium, sodium, calcium, magnesium. So you can compare in terms of reactivity, sodium, calcium, and magnesium. So highly reactive metal, more stable. Less reactive metal, less stable carbonates. So you can mention here, like more reactive metals, their carbonates are stable or hard or difficult to decompose. Or you can also refer the period and the groups. You can mention like moving from sodium to magnesium, the thermal stability decreases, means moving across. But as we move down the group, the thermal stability increases. So you can compare in terms of reactivity, you can compare, but the question is actually in terms of the reactivity series, that's why we use a reactivity. But I'm saying, what if it was not written like this? It was only written, describe how the thermal stability depends on the position of these metals. If the reactivity series was not part, then you can refer the period and the groups. The reason you're not supposed to learn a reason in IGCSE, in A levels, you will learn the reason why as we move across the thermal stability is decreasing and moving down the thermal stability increases.